Fourth grade, our next lesson is actually a combo lessons between two. We're going to be combining 9 and 10 together, and today we are comparing mixed decimals on a number line. That might take you a moment to fill out, so pause this video if you need to, finish your table of contents, and then let's come back to finish this together. I noticed that on my page I have 3 tasks, task 1, task 2, task 3, and they all have to do with our objective today, which means I can compare the value of mixed decimals utilizing a number line. So it looks like we'll eventually be able to move our mixed decimals onto a number line and compare their values. Task 1, we're going to rewrite each length in meters as a decimal. 1 whole meter would be the length of this entire tape diagram. And from what I notice, none of these tape diagrams are completely filled out. So far for each of these tape diagrams, if I were to write my decimal, I would need a space for my whole number, my tenths, and my hundredths. Each of these show me that I have not made it to a full meter yet. So each of my decimals will have 0 in the whole number place value. The tape diagram is split into smaller units. They're split into units of tenths. I can tell because I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. The value that comes right after the decimal point is our tenths value. So however many full blocks we have shaded is how many tenths we have in our decimal. This has 1, 2, 3 tenths shaded in. The next value is our hundredths. And as you can see from some other tape diagrams, our 100ths are even smaller units broken into smaller pieces like so. This top tape diagram doesn't have hundredths broken into its tenths. We only have 1, 2, 3 tenths shaded in, which means we have no additional hundredths shaded. So when we have no hundredths, I make my hundredths place value a 0, 0.3, otherwise known as just 0.3. 30 hundredths and 3 tenths are of the same value. Let's take a look at your second tape diagram. Let's start with our tenths. How many filled in tenths blocks are there? I see 1, 2, and some extra. I'm not going to count these smaller pieces yet because it's not a full tenth filled in. I only have 1, 2 completely filled in. These additional shaded pieces are our decomposed hundredths. I can tell that there's hundredths because there's 10 within a tenth, and 10 times 10 makes 100. So I'm going to have to use my really good 4th grade eyes and check to see how many hundredths I have additionally shaded in after the first 2. 1, 2, 3, 4, 5, 6, 7. I count 7 hundredths. I also know that it's 7 hundredths because there's 3 blank ones left in the tenth. I would need 3 more to fill up the next tenth, and 7 plus 3 equals 10. Let's do it again. Start by counting up your filled in tenths, 1, 2, 3, and then your shaded in hundredths, 1, 2, 3, 4, 5. And let's do it again. 1, 2, 3, 4. I have no additional shaded in hundredths. So our final decimal is 0.40, 40 hundredths, also known as 4 tenths. Now we're going to order these decimals from least to greatest. It's easiest to compare decimals when they're all written in the same amounts. That's why we took the time to write these decimals in hundredths. So we're going to compare 30 hundredths, with 27 hundredths, with 35 hundredths, finally with 40 hundredths. First, I'm going to check that whole number and see if any of these have a number greater than 0. They don't, so now I'm going to move on to my tenths place. Which one has my largest tenth place? That is 0 and 40 hundredths. Now we're going from least to greatest, so my greatest, my 40 hundredths, will go all the way at the end over here. Okay. If I look at the remaining decimals, I have 2 of them with 3 tenths, 1 of them with 2 tenths. I know that 2 tenths is less than 3 tenths, so that's going to go all the way at the beginning. And now I'm going to compare these two values. They both have 3 tenths, so now I'm going to look at the hundredths. 0 hundredths versus 5 hundredths. Or I could even just look at the numbers, which is greater, 30 or 35. Which 2-digit number is larger? That would be 35 hundredths. Which means our second to last, or second to least, I should say, is 30 hundredths. We've completed the first 2 tasks on this page. Let's go over to task 3. Measure each of the beakers and record the volume in decimal form. If there are no hundredths, write a blank in that column. Well, we ran into that issue here. If you had a tape diagram that had no hundredths, we labeled that hundredths as a 0, 0 hundredths. We're going to do the same thing using this table here with ones, tens, and hundredths. If we come across a beaker that doesn't have a value in the hundredths place, we would simply just write a 0 in that column. For example, cylinder A. I can see the total amount down below here. 0 and 6 tenths means I have 0 ones, my decimal point, and 6 tenths. Because I have no hundredths, I'm going to put a 0 in its place. 6 tenths is the same as 60. Now let's do the same thing with the B beaker. 0, 3 tenths, 0 hundredths. Now the C beaker. 0 ones, 9 tenths, 0 hundredths. Now the D beaker, and I'm noticing I have a hundredths place value. 0 ones, 9 tenths, 7 hundredths. 0 ones, 1 tenth, 9 hundredths. Last one, beaker F. 0 ones, 4 tenths, 8 hundredths. If I look at the values of the decimals, it's easier to compare if I think of these numbers as 2-digit numbers. Instead of 6 tenths or 3 tenths, it might be easier for me to compare 60, 30, 90, 97, 19, 48. Which of these values is larger? We're going to compare using greater than, less than, or equal to. 9 tenths versus 6 tenths. If I'm looking at my chart here, that means I'm comparing beaker A with beaker D, or excuse me, beaker C, I mean. And 60 is not as large as 90, in the same way that 6 is not as large as 9. That's an easy decimal to compare. This one's a little bit trickier to compare because we've got hundredths and we have tenths. So we've got to think of these tenths as hundredths. Instead of thinking it as 0 and 6 tenths, let's think of it as 0 and 60 hundredths versus 0 and 48 hundredths. Which is larger, 60 or 48? 60. The last one, we're going to compare 0.3, 3/10, and 0.19, 19 hundredths. Because they're different decimals, I want to compare them both as hundredths. Our 3/10 will be the same as 30 hundredths. And which is greater, 30 hundredths or 19 hundredths? I hope you're saying 30 hundredths. So now we're going to be writing the volume of each of these graduated cylinders in order from least to greatest. Now, I know that you might not have the room on your note sheet, so you can use the space below in your notebook. We're going to start with the smallest amount. And remember, when we label it, let's label it all in hundredths so they're easiest to compare. 0 is the same across the board. So let's take a look at our decimals. Which is the smallest amount? 60, 30, 90, 97, 19, or 48 hundredths? If you said 19, you would be correct. We're going to start with 0 and 19. Now remember, this is liters, so I'm going to order it with liters. Since that's the smallest in the order, I'm going to use my hungry alligator mouth to say that the next number will be greater. All right, 60, 30, 90, 97, 48. We have nothing in the 20s, but we do have one in its 30s, so let's do 30 hundredths next. We're going to keep following the pattern. 60, 90, 97, 48. Next would be 48. Remember to label your liters. 60, 90, 97. $90 versus 97. 90 versus 97. It's close, but 90 hundredths is less than 97 hundredths. So lastly, we would place our 97 hundredths of a liter. That's the end of our first page. When you're ready, let's flip over and work on that next side. So in math, sometimes it's helpful to have rules. When do you know that a decimal is larger than another decimal? Well, let's start in this order and work our way down. When you have two mixed decimals, meaning that you have a whole number and a decimal number, the first thing that you want to do is start by looking at the whole number, the ones place. That's what comes before the decimal. Compare there, which is larger, 9 or 7? For us, it's 9. So 9 and 28 hundredths is larger than 7 and 28 hundredths. So what happens if you run into two mixed decimals where both of the whole numbers are the same? Are they the same? 9 and 9, they are. So next, let's look at the tenths decimal place, the one that goes immediately after the decimal point. 3 is greater than 2, so we're going to point our alligator towards the 38 hundredths versus the 28 hundredths. Okay, but Mrs. Schumann, what if I run into a mixed decimal where the whole number is the same, the tenths place is the same, and the hundredths place is different? If that's the case, then let's look at that final hundredths place. We're just going down the line and comparing the place values as they get smaller and smaller. The larger the place value, the easier it is to compare. We know 9 is greater than 7. But if we're starting to see those similar numbers, we work our way to the next largest place value. Since 9 is the same and 2/10 is the same, that means the next place value that we're going to look at is our last one, the 100th place. And since 9 is greater than 8, that makes 9 and 29/100ths greater than 9 and 28/100ths. But wait a second. What if we run into a situation where they're both in different forms or one is in a different form? That means that we're going to change both of them over to decimal form. For example, we have 236/100ths. I know that there are 100 hundredths in every whole group. And I can pull 200 hundredths out of this number. That makes 2 whole groups. That leaves me with 36 hundredths, which will come after the decimal. So now we have 2 wholes in 36 hundredths versus 2 wholes in 36 hundredths. They're equivalent to each other. Let's look at some examples of mixed decimals that might be in the same form or they might not be, and let's practice some of these rules. All right, I'm noticing our 6 and 6 are the same, so I got to go to the next place value, my 10th place. 3 versus 7. 7 is larger. Now these are both in decimal form, but I notice that this one is in decimal form to the 100th, and this is in the decimal form only to tenths. I learned in my last lesson, or on my last page, that whenever I have an empty hundredths place, I just kind of plug in a 0. 20 hundredths is the same as having 2/10. The 3's are the same, so I'm going to go to my next place value, the 10th place, and I'm going to compare 0 to 2. Since 2 is larger, our alligator points there. We'll do the same thing for this one right here. We have 5 and 8/10, 5 and 92 hundredths. Just going to quickly change this to 80 so that we have both of these in the hundredths place. All right, the 5's are the same. Go to the 10th place. 8 versus 9. 9 is larger. Now we're getting to some tricky things here. We've got a decimal and we've got a unit form. So let's change this unit form over to a decimal. 6 ones and 2 hundredths. 2 hundredths. Well, I know my next place value is the 10ths place, but they didn't say anything about tenths. If I don't have any tenths listed in my unit form, or if I have less than 10 hundredths, then I'm going to put a 0 in the tenths place. And then my 2 hundredths. All right, so now they're both decimals, but this decimal's in the hundredths, this decimal's in the tenths, so just real quickly, I'm going to plug in a 0 there, and now we compare which is larger. The 6's are the same, so I have to go to the next place value, the 10ths place. 2 versus 0. 2 is larger. All right, let's try this one right here. We have 8 and 39 hundredths, and we have 8 and 39 tenths. Okay, so we have an improper fraction next to the number 8. 39 tenths would be the same as saying 8 plus 3 and 9 tenths. 8 plus 3 and 9 tenths, well, 8 plus 3 is 11 and 9 tenths. Okay. Let's change 11 and 9/10 over to a decimal, but I can already tell it's going to be larger than what we've got going on here. So this is 11 and 9/10. And just to make things even, I'm going to plug in a 0 in the hundredths place so that both decimals have hundredths. And I can very clearly see I can stop at the whole number right there. 11 is larger than 8. All right, last one. Both of them are in unit form. Let's change them into decimal form. We've got 3/10, so that's 0 wholes, 3/10, 0 hundredths, versus 22 hundredths, 0 whole groups, and the number 22. Which is larger? Well, we have 0 and 0, so we gotta go to the tenths place. 3, 2, 3 is larger. Man, that was a beefy lesson. You guys did lots of comparing today. I bet you're gonna be super ready for that problem set next to tickets. So, good luck.